All right, let's do another video. Just a couple more problem-solving ones here. Oh man, what a beautiful jet I drew in this one. We got the airplane flying at a level of 1,000 meters. So there's your fixed number. It's not going to get any higher, any lower. So in our triangle again, we talk about what's fixed and what's variable. The plane is flying towards us, right? So we're down here on the ground. So that distance is changing, which means the distance on the ground is changing. And as the plane's flying towards us, then of course the angle's changing. So we've got a horizontal distance changing and an angle changing, which means we've got two rates. So that actually works quite well with our problem. So what's the ratio to use? Tangent or cotangent, right? So again, look at tangent is 1,000 over x, opposite over adjacent, or cotangent is x over 1,000. I'm going to use cotangent because when I cross multiply, way easier to work with. And again, derivative of cotangent is negative cosecant squared. We're putting in time, so d theta dt, because theta and t don't match. Derivative of x is 1, and again, x and distance and time don't match, so there's your rate. You got an angle rate and a speed of the plane. All right, so what's the moment in time? Well, we need cosecant again. So the question is, looking at our diagram, the 1,000 didn't change. The 2,000 is the moment in time. So we are actually given the cotangent ratio because we are given opposite over adjacent, adjacent over opposite. I want to use cotangent because I like my identities. I could have found my hypotenuse, right? A squared plus b squared equals c squared, found my hypotenuse, and then done all that as well. But we're going to basically work it out again, just reviewing some identities. So these are kind of neat things to do, is tie what you've done in the past to what you're doing now. Cosecant squared is 1 plus cotangent squared. Cotangent is 2,000 over 1,000, which really means it's 2, right? So cotangent is 2, 1 plus 2 squared is 5. So cosecant squared is 5. So right in here, I'm going to put my 5. I'm going to put in my dx dt, which is the speed of the plane, 100 meters per second, 100 meters per, what are we talking about here? 100 meters per second. Sorry about that, scrolling back and forth here. So again, 5 is cosecant, the 100. When you put this in, you get a negative. And again, sometimes when you solve a problem, you have to kind of deal with the context. Are we moving away? Are we moving towards? But we know the angle should be increasing. So we don't want to have a negative. So the idea then is that this really needs to be a positive 1 over 50 radians per second. So even though you get a negative answer here, we need to, again, understand the context of the problem, that the plane is moving towards us. It's moving, and my diagram is moving left. Doesn't matter if it's moving left or moving right. The negative comes from the cosecant and cotangent derivative. So make sure you solve your problem relative to what's happening with your angle. So 1 over 50 radians per second is the angle increase. All right, so let's do one more example here. Let's go to the hot air balloon rising. We got a filming, all right, so we got a little video camera down here. We're doing some filming. The hot air balloon is rising. What's fixed? The camera is a fixed distance of 100 meters. The height of the balloon's changing and the angle's changing. So I got two variables. I got two rates. Everybody's happy. I got to figure out if I'm going to work with the tangent or cotangent. And I can see already I'm going to work with tangent because I'm going to go 100 tan theta equals the height. And there you go. You put your derivative. Derivative of tangent is secant squared. Derivative of theta is d theta dt. Derivative of height is 1 times dh dt. So what was fixed? What's variable? How many rates? What's the best ratio? What's the moment in time? Moment in time, I need secant squared. All right, so then I look at the information given to me. Well, I wasn't given a whole lot of information other than the fact that my height is 2 times time, or dh dt is 2, so it's going up 2 meters per second for 5 seconds. So I got to do a whole bunch of work on my own in this question. And you could figure out this in a variety of ways, but this is one way of identifying that for every second it's rising 5 meters. So here's my triangle now. Here's my moment in time. And this is going to allow me to find secant squared. So again, I've got my opposite and my adjacent. Secant is the reciprocal of cosine. I could find the hypotenuse, or I can use an identity. So I have 100 secant squared d theta dt, and right, that's what I'm working with. Those of you who liked the old-fashioned, like Math 10, when you were basically solving for Pythagoras, right? A squared plus b squared equals c squared. You can work on the green side. Those of you who like the idea of it's an identity, you can work on the black side. But see, it doesn't matter. When you get secant squared is 101 over 100, or secant squared is 101 over 100. So, and that's what I mean. I think on our other examples, that's what we kind of talked about. It doesn't matter which way you solve the problem. I would choose to do the identity. I just think that's using a higher level of math than using what you did in Math 10. So now that you got your 101 over 100 for secant squared, you know your dh dt is 2. You get to solve for d theta dt. All right, you've got enough knowledge in trig problem solving to be kind of dangerous. So have at her, have some fun.